So today we're gonna start a new chapter. It's called Similar Triangles. But listen, guys, this chapter is included for the two classes, 9B and brevet. In the brevet class, it's chapter 9. But for the 9B, it's not called chapter 9 because we are working different because we have the same content. It's chapter 7, and the lessons are 7.4, 7.5, and 7.6. So if you are brevet student, you are watching, you can write on your copy chapter 9 similar triangles page 95. If you are 9B book students, you're going to write chapter 7 lesson 7.4, 7.5, and 7.6. Okay, now we're going to start working here on this chapter. Okay, I left my cam on purpose because I want to show you a trick how to see similar triangles. First, when I say similar triangles, it's not the same as you saw it last year in grade 8 when you were saying that it's congruent triangle. Be careful, it's not congruent triangle at all. Similar, they look the same, but they are not overlapping. If you put them, they don't overlap. If I look at those two triangles here, you can see that they look the same, but they are not overlapping. What does it mean, similar triangles? I will show you this in the second PowerPoint. First, similar triangle, what you're gonna learn in this chapter, how to identify similar triangles, okay, by corresponding angles, by using the case of similar triangle to prove the triangles are similar. If you look at those two men, okay, as I did zoom out, يعني, as I did zoom out or zoom in. So if you have something, for example, and you do zoom in or zoom out, those are called similar. You are, for example, making this figure times 2, or I'm making the figure divided by 2. So this is the meaning of similar. They look the same, but one is bigger or smaller, but there is a proportional relation between those two. So those two that I can see here, they are similar. Okay, one is smaller than the other one, but if I want to compare each part of this man, if I want to compare the head, the nose, the hands, there is a relation, there is a proportion between those two. It means perhaps the one is times 2, the other one double or times 3 or divided. Okay, to prove similar triangles, we have 3 ways. We have 3 ways to prove similar triangles. And once I have similar triangles, it means everything inside are proportional as a side. Angles, we will see. So I will start with the first case, how to prove. What is the definition? First definition, 2 triangles are said to be similar if the 3 sides are proportional and the 3 angles are equal. So when I have 2 triangles, if the sides are proportional and the angles are equal, it means they are proportional. And for example, if I have this one 2, this is 4, 3, 6, 4, 8, they are proportional because I'm multiplying by 2, and the angles are equal. And directly I can write the ratio, this هذه proportion. How can I write the proportion ratio AB over D is equal to BC over EF? I will tell you how. If the side AB is proportional to DE, so AB is over DE is equal BC over EF is equal to AC over DF, and I have a trick also how to write it. هلا to prove similar triangles, I don't need to prove all this. Again, we don't need to prove all this. We need to prove some of the parts. هلا we will see what. So this is the definition. Now we're gonna start. So when I say 2 triangles are similar, it means they have 3 sides are proportional or 3 angles are equal, but we don't need to prove every time 3 equal sides, 3 proportional sides, sorry, and 3 equal angles to say that they are similar. No, let's see how. We have 3 methods. It's very easy. So I will give you the tricks now. So how do we prove that the triangles are proportional? Are similar, sorry. Yeah, it's not moving. Okay, proving similar triangle. The first one is called AA similarity. So first way, look at me. I do my finger like this first. So I have here angles. So 2 equal angles. So if two angles are equal in the first triangle to the other triangle, so I can say directly they are proportional. So the first way is AA similarity and 2 equal angles. It's enough. And since 2 angles are equal, sure the third one will be equal. So to prove similar triangles, the first method is if 2 angles of one of the triangle are equal to 2 angles of another triangle, then the triangles are similar. I can directly deduce they are similar. Okay, so I have the first case, 2 equal angles. Okay, so if the 2 angles are equal, Okay, I can move a little bit my cam. I can. Okay. So angle A is equal to angle D, for example, and angle B is equal to angle E. So directly I can deduce that the triangles are similar. Once you deduce are similar, you can write the ratio of the proportionality. How we can write the ratio of proportionality? I will show you how. Now when I will write, my cam will stop, don't worry. So you're gonna write, this is the first triangle. I have it A, B, C. I put under, which angle is equal to A? Isn't D, so I put under the angle AD. Which angle is equal to B? It's E. I put under it E. Which angle now is equal to C? It's the last one, F. And to write the ratio of similarity, I write AB over DE. Did you see it? So the ratio of similarity is AB, I'll write it here, AB over DE. So this is the proportional relation, is equal. I move now. For example, I can write AC over DF, AC over DF is equal to now BC over EF. So this is the ratio of similarity. So when I have two equal angles, I can deduce that the two triangles are similar, and I can directly deduce the ratio of similarity. You write the angles that are equal under each other. So A is equal to D, B is equal to E, C is equal to F, and then write AB over DE is equal AC over DF is equal BC over EF. This is the first method to prove similar triangles. Second method. So conclusion, did you see the conclusion? They write the two triangles are similar and I can write the ratio. Now see this figure. If I look at this figure, I have here 10 degrees, 50 degrees. Here I have 120 and here I have 50. If I look like this, we're going to say, no, they are not similar. Let's go and calculate the third angle. If I calculate the third angle, if I want to calculate this one here, it's 180 minus 50 plus 10. Why? Because the sum of the angles in a triangle are 180. So I have 50 plus 10 plus this angle, if I name it x, they are 180. I have 50 plus 10 plus x is equal to 180. So what will be x? 180 minus 50 minus 10. Or it will be x, the angle it will be 180 minus 60. So what will be the angle? 120. So I can see that now they are similar. I can stop here, no need to continue. They are similar since I have two equal angles. I have 120, 120, do you see it? And I have 50 and 50. So those two triangles are similar, having two equal angles. That's it. I'm done with the first example. And the other case to prove similar triangles. Now, let's go to the second case. Now do your fingers too like this. Okay, so I have side, angle, side. But we don't have to equal side and, no, we say an angle between two proportional sides. So I have an equal angle between, we say, two proportional sides. The side should be proportional. Let's see here. So if we have an equal angle between two proportional sides, so there are some, look at this figure. It's given A is equal to D. 5, 10, 11, 22. So there is a proportional. 5 times 2 gives me 10. 11 times 2 gives me 22. So the triangles, I have a proportional relation here times 2. Or one is half or one is double. It's like how we are reading it. So those two triangles are similar. Since I have an equal angle and two proportional sides, I can see it. A is equal to D is given. And if I do 5 over 10, it's half. 11 over 22, it's half. It's equal. Oh, I can do 10 over 5, it's 2. 22 over 11, it's 2. So the two triangles are similar, having an equal angle. This is the second case. An equal angle between two proportional sides. So I can deduce directly that those two triangles are similar, having an equal angle between two proportional sides. You can write here the final answer. It's half. So the proportionality ratio here, it's half. يعني هيدا, the big one is double of the smallest, or the smallest is half of the biggest one. Okay, so the second one is the two triangles are similar, having an equal angle. I have A and D are equal between two proportional sides. This is the second one. Let's go to the last one. 3. 1, 2, 3. I have 3 proportional sides. If the 3 sides are proportional, so it's a similar triangle. They are similar. So if the measure of the corresponding sides of two triangles are proportional, then the triangles are similar. If I look at this given here, look at it. 10 times 2 times 10 times 2, 5, sorry, times 2, 10. 8 times 2, 16. 11 times 2, 22. So the three sides are proportional. What can I deduce? That the two triangles are similar since they have a ratio between the sides. And there is one triangle double of the second one. How are they similar? They look the same. They are not congruent. They don't overlap. But there is a relation between those two. And as you have a figure, I'm going to zoom out or zoom in. You are zooming the picture. When you are zooming a picture, guys, هيدا عم نعمل أنا similar pictures, okay? So in given I have the ratio are equal. If I do AB over DE, it gives me half. If I do BC over EF, it gives me half. AC over DF gives me half. يعني they are proportional. I can take the bigger over the smaller. You can choose any way you want. If you take the bigger over the smaller, it will be the ratio 2. So I have this relation, so it means that the triangles are similar. It's very easy, okay? And then that's it. Now let's see here. So if it's given similar, look at this. 5 times 3 gives me 15. Okay, or I have the ratio. Now, if I want to find the other one, I know that it's similar. 4 times 3 gives me 12. Now, if I want to find the inverse one, 8 divided by 3 gives me 6. So if it's given the two triangles are similar, we can find missing lengths. So I know that those triangles are similar. They told you find the missing sides, so I can directly find the relation and find all the missing sides. That's it. So every time you need to think about proving similar triangles, okay, you need to think about mark the given first, okay, try to mark if there is a shared angle or vertical angles and choose one of the method or AA or SSS or SAS. يعني we have two equal angles هذه one, two an equal angle between two proportional sides, and three proportional sides, and that's it.